Pretty much. All right. Questions from the homework? Any questions from the homework? Come on, guys.
I'm pulling it up.
Yeah, number 11. Okay. Oh, I should do this the other way. We go here. Yes. Okay, number 11. It says simplify the expression. Let's put it on the board. It says 2 sine pi over 4 cosine pi over 4. The goal here is to simplify without the advent of a calculator. The trick with this problem, if you look very closely, it matches one of the forms on the board. In fact, a number of the problems from the homework match one of the forms we talked about last time. Here they are. This is actually an exact match to one of these right sides. We will then use the other side to rewrite as simplified. So this is, again, designed to use it without a calculator at all. So first question, look at the form of this. I have 2 sine of something, cosine of something. Does that match any of my formulas over here? Very top one. What does the top one say? It says sine of 2 theta is equal to 2 sine theta cosine theta. So if I want to use this formula, the 2 matches perfectly, so that's pretty good. But what's my theta in this case? Pi over 4. So I've got the 2, I've got the pi over 4, I've got the pi over 4. So what I'm going to do to write this problem in simplified, did I write that wrong? Ah, okay, thank you. See, that's why I asked if I wrote it down wrong. I wanted to know.
Wait, you wrote what down wrong?
I wrote the problem down wrong. Okay, so let's try number 11, round 2. We have 2 sine of pi over 4, cosine of pi over 4. Wait, I just did it again. Say 2 there. 2 cosine of pi over 4. Okay, so what I'm going to do first, I'm going to simplify this algebraically first. So I'm going to multiply things together that I can multiply, and see if I can make this, again, match one of these forms up here on the board, or at least get really close to it. So the first thing I'm going to do, I have a 2 in a weird spot. So let's move that 2. Property of algebra. I can change the order of multiplication. 2 times 3 times 4 is the same as 4 times 3 times 2. The order is not important as long as you multiply all of them together. So what I'm going to do, I'm going to move this 2 up front. This becomes 2 times 2 times sine of pi over 4 times cosine of pi over 4. Now you might be asking me, Douglas, why didn't you multiply those together? Strategy. Look at what I have now. I have 2 sine pi over 4 cosine pi over 4. Look at this piece. This piece by itself, with the 2 out front, matches perfectly to that top formula. That's good. I'm going to now use that top formula the same that we just talked about. Now, could I multiply those together and get 4 cosine of pi over 4 times sine pi over 4? Yes. But then it's kind of weird to look at it and go, how does it fit with one of these? Oh, it's close to the top one, but I have to modify it, and I end up having to switch it back out anyways. My goal for these problems is to make it match one of the formulas. I just did. So now, the formula is, again, this becomes sine of 2 theta. But in this case, my theta, as Garrett said, is pi over 4. This becomes, the 2 out front stays out front as a 2. The 2 sine pi over 4 cosine pi over 4 is replaced by sine of 2 times theta. So it's 2 times pi over 4. Okay, I simplify some more. 2 is going to say 2. Sine of 2 times pi over 4. 2 times pi over 4 would just become pi over 2. This is one version of the solution. I can also use the unit circle to find the other version. Sine of pi over 2, I go to my unit circle, go to pi over 2. Go to the sine value, pi over 2 is here. Up here's the sine value, so that says that is 1. So 2 times 1 would mean this answer is 2. Now, If you check the back of the book, I believe the first answer is what they have written down because they want you to not use a calculator at all and not use the unit circle at all. The goal is just to simplify using the formulas. This is, again, a common approach to trigonometry. It is not necessarily to find an exact solution. It is to modify the way it looks, modify the way it feels by restructuring using other trig functions. So we change this function from being the product of 4 things multiplied together to the product of 2. 2 times sine of 2 theta. Much simpler in terms of how we approach it. Thank you for that question. That was a good one. And thank you for correcting me when I wrote it down wrong. Okay, so that was number 11. Any questions on number 11? So I rewrote the problem first. I then tried to force it to match one of my descriptors, which in this case was the first one. Once I match that descriptor, I can then move forward and try to figure out how to rewrite it, which I did here, and then I simplified to get to that solution. Again, this is the solution the back of the book would give. If you plugged it into a calculator, that's the solution it would give. They're the same thing. Questions? Other ones? For the homework? Yes, you better believe that's what I would do. So number 12 fits the same basic way, but number 12 is as if we put these together. Okay, so number 12 says, and correct me if I write it down wrong, 4 sine of pi over 8 times cosine of pi over 8. Without a calculator, this problem is almost impossible to do unless I use like a bunch of weird rules from last section. Instead, what I could do is rewrite this function to try to match it to one of my forms. And then when I rewrite it, hopefully it comes out in a better form that the unit circle solves it for. Here we go. I would break this 4 up into 2 times 2. Why into 2 times 2? Because now the 2, the sine, and the cosine all match the first form. So I write the problem. 2 times 2 times sine of pi over 8, cosine of pi over 8. Which again, that should be obvious. These two are equivalent because, well, 2 times 2 is 4. But now this perfectly matches our system. 2 sine pi over 8, cosine pi over 8. We can replace that with our first form, sine of 2 theta. So this becomes 2 times, instead of 2 sine pi over 8, cosine pi over 8, we replace it with the first form, sine of 2 theta. So 2 pi over 8. Like that. And then we simplify what we can. This would become 2 up front still. We haven't touched it. Sine, still sine. 2 times pi over 8 will become pi over 4. And again, this is the solution the back of the book should have. If you plug into a calculator, you end up with square root of 2 again. But again, the goal is to work without a calculator, without unit circle entirely, just using and understanding the formula. Controversial fact. The higher you go in math, the less concerned you are with reality. So I know many of you guys out there are going a lot farther in math, and that's fine. We talked about this many times. The farther you want to go, though, you stop worrying about what the exact value is. And that solution is a great solution. You look at it and go, I don't really care what the number is. I was able to rewrite it. That proves I'm smarter than you. Really, it's that bad. Like, math people are terribly arrogant individuals. You haven't caught on yet to this guy up here at front. Yes? All right, I got time for one more question from the homework before I want to move on. I'm going to get plenty of time today. That was number 11 and number 12. Any others? Okay. Well, in that case, take a moment. Take your notes out. We have our first problem on the day. This is how our problems are going to look like for all of today. A relatively short assignment for tonight. These are by and far the most important questions in the entire chapter, are questions of this style. We have already experienced questions in the last section that were similar to these ones. We will experience questions in this section that are similar to these ones. And we will experience questions in the next section that are similar to these ones. These are the most common applications of upper level trigonometry. So, first on the board, we're going to solve it together and talk about how. Yesterday at the end of class, we wrote down 4 steps. Those 4 steps are going to be at play today, so I hope you wrote them down. They were. Step 1, draw a picture. Draw the triangle using the information you are given. Step 2, Pythagorean's theorem, very common.
This notes.
This is notes, our first example on the day. Step 3, once we've got Pythagorean's theorem in that triangle, we're going to attempt to find the function. So we're going to write sine of 2 theta, cosine of 2 theta, tangent 2 theta, using the rules up above. And then finally, once we've done all of that, we have to plug in and simplify. That last step sounds short, but as you've seen in the past, simplifying is often a lot of algebra. So let's talk about this problem as our first example of the day. We're going to try to do at least 4 of these. Hopefully get a lot of work in and see how you feel. Here we go. If tangent of theta is equal to negative 5 over 8, and theta is in Q2. That means it's in the second quadrant, which means it is over here. Yay! Quadrant number 2. Remember, we talked last section, about the importance of knowing the quadrant to determine things like the sign of the function, whether it is positive or whether it is negative. That will also be at play in that simplified part of the problem. Okay, the problem says, find sine of 2 theta. I'm going to put most of this information to the side, including what we're looking for, because the first 2 steps do not give a dang what I'm looking for. They care, can I draw the triangle, can I use the Pythagorean's theorem? So I will make that my first priority. All this stuff about what I want to find, I'm going to pull over here. Let's draw the picture. As we talked about yesterday, step 1. Come on. Step 1. I want you to be able to take this function and use it to draw a picture. I have tangent of theta is equal to negative 5 over 8. Let's draw the picture. We discussed before. Triangle, not terribly important in this class. Make sure it's a right triangle. Make sure you know where theta is. Try to be consistent. And we're going to take the information in this problem. We're going to put it into this picture. Let's do it. Negative 5 over 8. As a reminder, tangent is related to the sides of a triangle from back in geometry and last semester. What is tangent? That's true. That's true. Opposite over adjacent is also true. So in trig, you start to get to this point where there's so many answers to that question. If I'm dealing with a triangle, I want to do opposite over adjacent. If I'm dealing with an identity or a theorem, I want to use sine over cosine. So make sure you keep the 2 separate. They are both true, but one helps me with this picture, the other is not as helpful. So both of you are correct. I'm going to use Garrett's though. So I do opposite, negative 5 over adjacent 8, making sure to put it in the correct spot for tangent. And step 2 is now we're ready to go. Step 1, I draw my picture with the information that was given. I have tangent, I have a triangle, I have put the sides in. Now we do Pythagorean's theorem. Luis, help me out, buddy. Would you do Pythagorean's theorem on this problem? And tell me what you get. 89? I don't get 89, you fool. You're crazy. I don't get 89. What come on, 89? Square root of 89. Be careful. Be careful. Alright? Now, these first 2 steps, have I dealt anything with sine of 2 theta? No. Have I dealt anything with cosine of 2 theta? No. Have I dealt anything with tangent 2 theta? No. The problem doesn't care about those processes. These 2 steps are constant. Now I start to look at the problem. The problem says I want to find sine of 2 theta. Well, I now know that sine of 2 theta is not just sine of 2 theta. It is something else. I'm going to now do step 3. I'm going to look for a formula to rewrite this function. I want to find sine of 2 theta. I can't find sine of 2 theta with this picture. But what I can do is find things like sine of theta and cosine of theta, both of which are in my picture. So again, I cannot do the problem sine of 2 theta, but I can do the alternative version. That's why there's so many different formulas. It's because I can't do the way it's written, so I just rewrite it and do it that way instead. It's like cheating, the best way. Let's do sine of 2 theta. So according to my problem, sine of 2 theta is going to be equal to 2 times sine of theta times cosine of theta.
20 or 2 theta?
2 theta. I pulled it right here from my formula. Okay? So I want to find sine of 2 theta. I know I'm looking for sine of 2 theta. I rewrite sine of 2 theta. That is step 3. Step 4, plug in and simplify. This picture will tell me what sine of 2 theta is. Or sorry, what sine of theta is by using sine and cosine of just theta. Good. So we have 2 times. You got -5 over square root of 89. How in the heck did you get that? Look at the triangle, right? So we got the triangle, right? He remembers that sine is opposite over hypotenuse. So he pulls in the opposite, -5, pulls in the hypotenuse, square root of 89. Good to go. And then cosine. What is cosine? 8 over square root 89.
Square root 89. Times.
Okay, so last step was, so whoa. Don't go too fast. Step 1, we do the triangle. Step 2, use Pythagorean theorem. I'm still going too fast. Sorry, I got a lot of energy today. Okay. It's snowing. You open the door. So, here's the problem.
No. I'm freezing.
Why?
Here it's cold.
It gets too cold up and close the phone.
Sorry, it's too cold. So go ahead.
Alright. Step 1, we drew the triangle using the information they gave us. Step 2, with that information, we then use Pythagorean theorem. Thank you, Luis. Beautiful. Step 3, we then use the information we know from our formulas to rewrite what we want into a better form. Step 4, we are now plugging in and simplifying. I am at this step right now, which is the last step as long as I can simplify this, so let's do it. Sine of 2 theta is equal to, according to our function, 2 times -5 over square root of 89 times 8 over square root of 89. I need to simplify. What am I going to do? Okay, so I'm going to leave the 2 because you didn't say do anything to 2 yet. So this would be multiply the top times the top and the bottom times the bottom. I'm just showing all of my work. Normally I would not show all these steps. Okay, so Madeline, I think you told me what happens to the denominator. What happens to the square root of 89 times square root of 89? It's just 89.
Oh, this is so confusing.
What happens to the other 3 pieces? The 2, the -5, and the -8. Sorry, the 2, the -5, and the positive 8.
So it'd be 2 times -5 would be negative. I would call it like a negative 2 times 8. So -80.
Why are you multiplying 2?
Because 2's over 1. Basically.
I'll get the 2. I'm not going to that.
Okay, cool. Ask your question one more time.
I was just thinking.
Okay.
2 times that, so it's 8 over 89.
Yes, again, I pulled this directly from the formula.
But
This piece came from the picture.
well, everyone else has to make it
Oh, yes. These are all times.
I thought so, but I just wanted to check. Don't laugh at
No,
me.
I'm not.
Yeah, I'd be like,
Okay.
You multiply today.
I don't need to.
Because the square root of 89 times square root of 89 is just 89.
So in this case, it's a special case where if I just simplify it directly first, I never need to fix the radical denominator because the radical fixes itself. If, when I simplified it this way, the bottom still had a radical in it, I'd have to take the next algebra step to get rid of that radical. But in this case, it happened to disappear algebraically before I tried to simplify it. Okay? So, let's go ahead and make sure we're on the same page with these couple steps. Step 1, I use the information in the problem to draw a picture. Step 2, we use that information to find the missing side. Step 3, we rewrote the problem, which was sine of 2 theta, using our formulas. Step 4, we then plug into that equation and now simplify everything. The simplifying is all algebra, but you have to get the previous steps right in order to do it. If I mess up on a previous step, I cannot do this step.
So that's sine of 2 theta, right?
Yep. And this is one that the calculator cannot solve without these steps. These are, again, problems that a calculator can help because it can do these last couple steps, but it can never go from the original example to that answer without you doing work.
I still don't understand how you guys get that once.
Okay. So the problem asks us to find 3 things. We found the first one. Let's go through number 2 and number 3 real quick. So, one more time. How I found my first solution. So in this problem, my first solution was -80 over 89. Now I go to problem number 2. Problem number 2 says find cosine of 2 theta. I'm going to scroll back up. All right, let's do this. So my first answer we said was negative 80 over 89. Okay. What's for the next couple answers? All right. So the nice thing about these multiple step problems is that once you've done one of them, the other ones are much easier to straight. Let's take a look. Because I can skip the first two steps, right? I've already got the picture. I've already done Pythagorean's theorem. I don't think there's only one problem in your homework that has you do all three of them, but the rest have you do one of them, which means you basically start over at square one every time. Let's do part two. Cosine of 2 theta. So we've got the picture. We've used Pythagorean's theorem. That's good so far. Now I need to find cosine of 2 theta. So I'm going to go down here. Cosine of 2 theta. Now, you'll notice that there are multiple versions of cosine of 2 theta. I can choose which one I like the most. In general, the book primarily uses the first equation every time. So if you look at the book on this example, it does the first equation. If you use the other two, you'll get the same solution. It's just different steps along the way to get the same answer. So I'm going to follow the book's recommendation and do the first step. Cosine of squared of theta minus sine squared of theta. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta.
Oh, this is.
Take a deep breath. Come on. Not that bad.
No, it's just long.
Yeah, I can't help that.
So let me just get this straight. You're gonna make us test over this and what we learned from the last section all together?
Actually, I was thinking about doing a little quiz at the end of this section. That way we don't have to do a big test.
Oh, I'm literally going to puke.
Well, the door's open. Please puke outside. No, it's easy. Take a deep breath. You'll be fine.
No, I already forgot what we learned last section because I focused on
Don't
it.
even start with me.
Oh
Alright.
my gosh.
Yeah, you could. Melon,
I think we should just forget
why
what
don't
we
you do that
learned
one
last section.
while we do this one and see if we get the same answer? We should, right? Well, let's find out. Okay, so now I've got my equation. I rewrote it as cosine squared minus sine squared. I want to plug in and get my solution. So I do cosine squared. So I write the cosine function and then I will square it. According to my picture, the cosine function is adjacent over hypotenuse, so that'd be 8 over 89. So the cosine function squared minus sine squared. I do my sine function and I square it. So I go to my picture. My sine function is negative 5 over square root 89. And I will be squaring it. So I get this solution. I have plugged it in. I now must complete step 4 by simplifying what I can. So let's simplify some. Alright, one more time. I took my equation. I used the picture with Pythagorean's theorem to rewrite this equation as cosine squared theta minus sine squared theta. I have plugged in. And I'm now simplifying. Let's do it. Alright, algebra time. Let's see who remembers their squares. Say again, Melon. Good. So, we end up with this problem. Take a look. Make sure you understand where it came from. 8 squared is 64. Square root of 89 squared is 89. Squared and squares cancel. Minus negative 5 squared is positive 25. Remember, negative times a negative would make it positive. 5 times 5 is 25. And square root of 89 squared is 89. Last thing, I'm going to finish simplifying this. I have 64 over 89 minus 25 over 89. Those two things, 64 over 89 minus 25 over 89. What is that? 39?
Yeah, you're
And that's my solution. And you get the same solution going the other way? Good. So Madeline tried it using the second formula, and it got the same solution. So that's how you know these things work. Like they should be the same solution. You can pick any one of them. Just pick the one you want to work with. So, part 2 is done. This problem is, it turns out part 3 is the easiest from the beginning, but has a lot of simplifying.
I thought we were just looking for sine.
No, we did cosine now, we did tangent. How did you say find out 3 Levi? Come on.
Person, what did you say all three? If any.
What the fuck?
Alright, let's add it to our list. We got 39 over 89. Before I go on, anybody have any questions about where those two answers came from? Let's do tangent. Tangent of 2 theta. So I'm going to follow the same process before. I know tangent of 2 theta is not just tangent of 2 theta. I'm going to rewrite it first. I'm then going to plug in and simplify using the problem that I got from the triangle and Pythagorean theorem. Once you've done one of these, they all start to feel very, very similar. It's just a lot of algebra at the end to simplify it down to one solution. And the nice thing is, the calculator can't help with the first couple steps, but it can help with that last step. So use what you can. Here we go. Last part of the problem says, find tangent of 2 theta. I'm going to come over here. I'm going to erase my work. And we're going to start working on tangent of 2 theta. So, step 1, just like before. I've got my triangle. I know Pythagorean's theorem. Found the missing side. I'm going to rewrite tangent of 2 theta using my formulas. Tangent of 2 theta is equal to, according to my formula, tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So I get
times
equals 2 times tangent negative 5 over 8 is on top.
1 minus.
I put this in parentheses to remind myself that I have to square it at the end. Negative 5
Over.
That's it.
Calculator.
Yeah, actually on this part you can totally plug it back there. I'm going to do it by hand to finish this, but yeah, you can grab it back at this point and plug it in. So, if you're going to do that, go ahead and do it real quick. Alright. Now, there is an alternate way to find the solution. If Cole brings up something he talked about a moment ago. We want to find tangent of 2 theta. Another way to think of tangent is sine over cosine. So to find the tangent value, I could have also just taken the sine answer we got divided by the cosine answer we got and gotten our solution, which was negative 80 over 39. A little faster. Tangent is usually the best one at this point because you can usually cheat a little bit and use another property to get there instead of using this property. Remember, all the properties are equal. I could use a sum difference problem to do it if I wanted to. I just have to be creative in how I use it. I could use the tangent property to do it, using the quotient rules. I could use these rules. Like, I have so many options available to me, and you can do one to be like, hey, I did it this way, and then do it with another one to get exactly the solution as we did a moment ago with that one. Like, it works. That's why these work. It's because they are all interconnected. They all work together. These ones are good practice using the double angle formulas. In your homework, there are 2 types. One set using the double angles, one set using the half angles. The half angles work the same way with one exception. The half angles, use the half angle formula. Okay? It's not that hard. So, before we do a half angle question, we just did one part of the half angle question because they're all the same. Are there any questions over this part of the homework tonight?
It's kind of easy.
It has a lot of algebra fixed in, right? The last part especially. If you don't have a calculator to help fix that problem, it is a lot of algebra at the end. But, as we've seen, and we will continue to see for these kinds of questions in this chapter, this is the largest part of your test. Because we've had questions like this that were for the sum difference rules. We've now had questions like this for the half and double angle rules. We will have questions like this for the next section too. These questions, this style, using these 4 steps, make up the majority of this test. Yes, it does.
I have a question.
Yes, sir.
Actually, just do it.
Okay.
It's over the
I'll try to make sure I got plenty of time. Okay. We're gonna do one more. It's a half angle formula. Because of the weird way the half angle formula is written, it is less fun. Because it's kind of radical in it. A calculator is your friend to the half angle formula. And keep in mind, if you are not allowed to use a calculator for that portion, go as far as you can and then stop. Okay, here we go. Similar style of question. You're going to see it's written very similarly. Question before I go. Question. All right, let's do it. This is actually one of your homework questions. Yes, this is number 20 in your homework. It says.
20 is our homework?
Yeah.
Where does it say? It just says 11 through 19.
Yeah, but we have new 7%, remember? It's regular product back.
Oh, yeah.
20 says, if.
This is part of our homework, is it? Yeah.
So, you know what? I'm going to choose 22 instead. Make it a little different. 22.
Is this our still on our homework?
Yep. If cosecant of x equals 7 and x is in.
Is that cosecant of x equals 7 or cosecant?
Yes.
Okay.
Is in quadrant 2. Fine.
What's the quadrant? Like what does
That
the
just
quadrant?
tells you it's positive or negative, basically, right?
Yes.
So it would be positive.
Oh, yeah.
Because 1, 2.
Yep. Find sine alpha over 2. Now your homework says to also find cosine and tangent. So we're just going to add 2 more steps to it. Once we've done the first step, the others will be easier. Okay, just like with the previous one, 4 steps. We will draw a triangle. We will use Pythagorean's theorem. Once we have those 2 things, we will then rewrite the formula, plug in the formula and solve. Plug in the formula and simplify. Let's do this. Step 1. I draw a triangle. Now, it's been a little while since we talked about cosecant. You may want to look at your rules for this one. It says cosecant of x is equal to 7. How do I put that into my triangle? Aha. So remember, cosecant is hypotenuse over opposite. It is on your cheat sheet as that way. But that would mean I need a fraction. I don't have a fraction. Number 1. This becomes 7 over 1. So now, how do I take that and put it into my picture? Now, the picture says it's a problem involving x, so I put an x in my picture. And now I do exactly what Madeline was talking about. I do hypotenuse over opposite. So 7 over 1. 7 is my hypotenuse. 1 is my opposite. There we go. I'm going to make it a fancy one. Let's stand up. Boom. Okay, step 1. I've gotten this problem now into a picture. Any question about the first step? That first step's a little wonky. If you haven't remembered it. All right. Step 2. Pythagorean's theorem. There we go. Pythagorean's theorem, please.
Page 1.
Square root of 48.
Square root of 48. Beautiful. All right. We want to find sine of alpha over 2. We have drawn the picture. We have used the Pythagorean's theorem. I'm now going to attempt to find sine of alpha over 2. So according to my formula, sine of alpha over 2 is equal to this very unique fraction. Sine of alpha over 2 is equal to, so plus or minus
1
square root of 1 minus
cosine.
cosine theta
Okay.
all over 2. Now, you ask where I'm going to go. Why is it important to remember your quadrants? Because for this particular example, something unique happens. Cosine should always be negative in the second quadrant. As a reminder,
So then that'd be plus
because of this quadrant 2,
right?
yes, this implies the cosine is negative. Which means when I go to this picture and pull out cosine, I can make sure it's a negative number. I'm going to force it to be a negative number by putting a negative into the symbol. You are right. What that's going to do is it's going to create a double negative situation. But I'm going to go ahead and show all my work. Here we go. Equals, plus or minus, big square root, over 2, 1 minus. I go to my picture. Cosine of theta. As a reminder, cosine must be negative. So I'm going to put a negative in the problem. And I do cosine. Cosine is adjacent over hypotenuse. So that's square root of 48 over 7. Now, I said to simplify as far as we can. I will showcase the couple steps I'm going to do to simplify this as far as I can. It is not as many steps as you think they're going to be, but it's also not going to be exactly the way you like it at the end. Here we go. First thing we're going to put down. Okay, I'm going to take rid of the double negative, so I'm going to put plus or minus, big square roots, 1 plus square root 48 over 7 all over 2. So I fix the double negative. Now, I have a fraction instead of a fraction. I'm going to combine and then use KFC. Okay, I'm going to combine and then use KFC. Somebody asked yesterday if you could go in a different order, if you could use KFC first by splitting them apart. Yes, there are a lot of algebra steps you can do here. I tend to follow the same ones every time. If you have your own version, make sure at the end you get the same solution and then follow through with it. Next step. I'm going to start by combining these two. So I'm going to turn this 1 into a 7 over 7. And then combine this. So this becomes plus or minus big square root. 7 plus square root of 48 over 7 all over 2. Now I'll use KFC to rewrite this function. And this will actually be basically my last step. With one thing left, I'm going to pick the positive and negative. Here we go. Equals, I use KFC, plus minus, square root. I end up with, so the KFC will cause this to become 7 plus square root 48 over 7 times, the 2 becomes a 2 over 1. I do KFC. KFC says keep flip change. So I keep the top, flip the bottom, and change the multiplication like so. Last thing, I make this equal. It's a big square root. 7 plus square root 48 all over 14.
That's your answer?
That's what I would use. That's what I'd probably plug into a calculator. And be like, hey, let's put this as a decimal or something else and see if it simplifies more. Now you notice that I've dropped the positive and negative because now I'm going to answer the question which one. To do so, I'm going to go back to what it originally said and try to use some logic and reasoning. The problem said we are in the second quadrant. So as a reminder, we are over here somewhere. The problem asked for theta over 2, so it's cutting my angle in half. That will cause my angle to shift to a new location. Where it shifts determines the answer, whether it's positive or negative. I am in quadrant 2. If I cut this angle in half, no matter where in quadrant 2 I am, if I cut it in half, it will end up in the same answer quadrant. Quadrant 1. Pick any number in here and it's true. Pick 120. Cut that in half, it's 60. That's in quadrant 1. Pick 150. Cut that in half, it's 75. That's in quadrant 1. Pick 179. Still in quadrant 2. Cut that in half, you end up with 89.5. It's still in quadrant 1. That is why the answer for this problem, since I am in quadrant 1, all functions are positive. This is my answer, the positive version. I put the plus sign there to remind myself that I checked. Otherwise, I might convince myself that I haven't checked yet. It has to be the positive answer because of the fact that we started in quadrant 2. That last step is the weirdest step. So I'm going to ask and make sure we're all okay with that step because it's a weird step. To do the last portion, to tell myself whether this is positive or negative. Remember, there's two possibilities, either the positive number or the negative number. I ask myself, where am I at right now? I started in quadrant 2. If I cut this angle in half, I'm going to end up back in quadrant 1. Every time. There's no way around it. Question. Like I said, these are the biggest part of your test. If you want to know what to study for your next quiz, which will be taking place likely on Monday, if you want to know what to study, questions like these from this section and the last section are it. It's the big piece. The proofs, like, there's like one question, maybe two. These ones, the big boys. The other ones. Questions? Tomorrow we'll start the same way. Question from the homework, and then finishing out the section. We will finish the section tomorrow. Friday, I will answer questions from the homework, because the homework is due on Friday. Thursday will likely not be in here. So, that is happening. Your homework for tonight is in the same section. It is section 9.3. We're adding in problems 5 through 8, 20 through 23, and 5 through 8, 20 through 27. The nice thing about this last group is that some of these already have the picture drawn for you. They've helped you. Use that to your advantage, please. Don't draw in a picture. Alright, there's more for that. When you post these two classes momentarily, tomorrow we'll come in, ask questions, and finish this section.